Hello class CSC 380 and Professor Gamel. This is Daniel Bazan from Artificial Intelligence. Today I will be talking about the AI library to solve the 8 puzzle. Bear with me here. It ran out of time to write my user interface, so I will be using this run button over here to run all my methods and show the solution. So here's the main menu as it spits out all the options that the user has, and then it takes in the input. First, the method we want and the difficulty we want. Up here, comment out, but as point of reference, the different states, or the initial states and the goal states. Basically, what I have is my states are represented by strings, start and goal over here. Temp state is also a string. This will be the newly found state each time we find a node. Here's the queue that stores all of our nodes. The depth map takes that the depth at which the node was found, stores in there, and then we find the parent of that node. Next nodes for space, depth is already mentioned. Solutions to determine whether we found a solution or not. Easy peasy. And then here we have start and final time. End time is done near the end of the output. Okay, so here we go. Prep for search on DC. We have very quick input. Medium, same thing. And hard. Slightly different for prep for search. Slightly larger, but it's still really good. 75ths of a second. So basically, we're scrolling down here. After we've taken the input, set the initial states. We go through here, initialize the queue. Here is our main search. Checks if the queue is empty. If it's not, then we remove one off the top. That's our state. Checks to see if that's our goal state. We set that boolean to true, and then we break out of this while loop. Otherwise, this is where the main search comes in. This part. So the first part checks to see if the blank is not in the leftmost column, which means it can go left. And the way that's done is it takes in substring of that temp state up until 0, and then adds the character, and then adds the rest of the substring, and that's our new state over here. And then that gets added to the queue. Same thing can be said over here. Up, it can only go up if the blank's not in the topmost row, right? This is not the rightmost column, and down is not the bottommost column. So that's going to be iterating over and over until we find a solution. That's our solution output, and then we have to initialize for the output and the directions. Okay, here's our queue and our duplicates. So this checks the duplicates, see if that child is already found in the depth map. Really, obviously, we visited it's going to be a repeated state if we find that state at the same depth. So this if over here checks to see if for the duplicates, and this is how we enter the queue. We basically add the child for breadth search. It's first in, first out. So we first add the child. So in the beginning, we will get parent will be the null, and the child will be the start state, added to queue, and then once it takes in the next 3, it's gonna be 1, 2, 3. The way breadth search works. So depth of search the next. A little bit harder on the runtime. You can see we get the solution, and then eventually I get the path taken, so that's a little bit slower. Basically, same deal as breadth first search, except the difference main here is it's last in first out. So we always add the latest found node gets added to the queue at top, so to reflect the last in first out method that the depth first search does. This is the greedy best first. It's Similar to the first two, except we did have to add a heuristic counter and an ordered. These keep track of all our found. It keeps track of all the um, misplaced counters, misplaced numbers from their respective boards. And so over here we represent my misplaced count. Basically, it iterates if basically compares position by position, see if it state matches the goal. So, and then if not, it keeps track of the count over here. And we put that into H1, and then we have that chart to the queue normally. And then our main reset of the queue comes in this part over here where we have to sort it. We basically take the keys and the values from that map, and then we have to sort it. And this is my sorting algorithm over here. Pulls the values, see if that value, if the value over here from the pool B matches the get key from the map. If it does, we pull that, we add it to the sorted keys list, and we add everything right back to H1, and then we repeat. Last but not least, we have the heuristic. We're gonna run it here. Real quick, real easy, no space taken. So similar to the greedy, the only difference at the bottom is that we do the +1 to the misplaced count to account for the G of n, which is the path from the beginning state to that node. Obviously, the cost of that is going to be 1. So it's going to be a +1 to H, and we add that misplaced count +1 along with the child into H1. So otherwise, it's the same code as greedy. Okay, that's about it. Feel free to go through my code, for my video, leave a comment. So yeah, just about it. Thank you.